Alright, so we did some basics yesterday with angles. Today we're going to pick up on properties of angles. So we started yesterday with two properties with complementary angles. What's special about complementary angles? Not 180. 90. They add up to 90. Our other relationship was supplementary angles. Those are the ones that add up to 180. We're going to talk about another couple more angle relationships, and then we're going to spend some time looking at what we call similar triangles. So the first thing we have is called vertical angles. Okay, when we have two lines that intersect, we create four angles out of that intersection. Vertical angles are the angles that are across from each other. Okay, the ones that are on opposite sides of that intersection. Those are called vertical angles. Those will be congruent. They will have the same measure. Okay, so if we know one angle, if I know the measure of angle QMR, I automatically know the measure of NMP. Okay, I also know the other two angles through supplementary relationships, because notice when we have two lines intersecting, if we look at one side, okay, so we look at this line, this is a straight angle. So these two angles together are supplementary. So as long as we know the measure of one angle on the intersection, we can find all of the angles using vertical angles and supplementary relationships. So the other thing that we have for our relationships is transversals on parallel lines. Parallel lines never intersect. They never touch. They're on the same plane. And then we can have another line called a transversal that intersects those parallel lines at any angle. Doesn't matter. And it creates a bunch of different angle relationships. And we're going to go through some of those. So you see that with the intersection of the transversal, we have 8 different angles, or 8 angles that are formed through that intersection. Okay? So the first type is called alternate interior angles. Okay? Alternate interior. 4 and 5 are alternate interior, as well as 3 and 6 are alternate interior. They are on alternate sides of the transversal. Okay, that's the alternate part. Interior, between the parallel lines. Alternate interior angles are congruent. They have the same measure. And then, again, using supplementary relationship, if I know the measure of angle 5, I also know the measure of angle 6, because their sum has to be 180. So as long as I know one of those angles, I can find the rest of them. Okay? Next one we have is alternate exterior angles. 1 and 8 is an alternate exterior angle pair, as well as 7 and 2. 7 and 2. Okay? Again, those measures are going to be equal. All right? Alternate, again, meaning they're on opposite sides of the transversal. Exterior, meaning they're on the outside of the parallel lines. All right? They will be congruent angles. Those matching pairs. Interior angles on the same side of the transversal. Okay? Those are going to be supplementary here. So we're looking same side of the transversal. Those will also have a supplementary relationship. So those will have to add to 180, as well as 5 and 3. And then corresponding angles are angles that are in basically the same spot relative to the transversal. So 2 and 6 are corresponding angles. They will have the same measure. 1 and 5 are corresponding angles. They will have the same measure. 4 and 8 are corresponding with the same measure. And 3 and 7 are corresponding with the same measure. So the thing with all these relationships, as long as I know one of those angles, that's all I need. One, I can find the rest of them. Okay? Using the fact that half of these are going to be congruent to each other. Okay? 4, 6, 3, and 2 will all be the same measure because of one or other relationship. And as well as 5, 8, 1, and 4 will be congruent because of one or another relationship. And then I can use the supplementary relationship to find anyone that's missing from the one that's given. All right? So we can use that idea to use algebraic or to just be given an angle measure to find those values. So So what we want to do to start with this one is I want to find the measures of angle 1 and 4. They're alternate exterior, so that means they have to be congruent. So if they're congruent, what can I do with these two expressions in order to solve for x? Let me rephrase that. What does it mean if they're congruent? So what can I do with those two expressions then if the angles are equal? Set them equal to each other. So I don't know what the measure of the angle is, but I can, since I know that these are equal, I set them equal to each other. And now I can solve for x. Okay? So what is the first step in that solution? Okay, then what? So let's subtract 3x and add 40. Okay, that cancels, so I've got 42 equals 2x. Next. Okay, so what does x equal? Okay, x equals 21, so now I need to figure out the measure of the angles. Okay, pick one. Which one? Okay. Okay, so 65 degrees is the measure of angle 1. So using those relationships, now we can figure out everything else. Okay, so what's the measure of angle 2? Angle 1 is 65. 65, which is what? Okay. I know the measure of angle 1. What's the measure of angle 3? 65, because they got to be congruent. I know the measure of angle 1. What's the measure of angle 4? Angle 4. 65. They're alternate exterior. They have to be congruent. Remember, we set them equal to each other. So if I know 1, I know 4. If I know 1, I know 3. Okay, using those relationships to find the missing angles. Before we go, any other questions on that? Triangle stuff. All right. So now we're going to go into some triangles, some theorems, as well as some vocab real quick. Sum of all the angles in a triangle has to add up to 180. We should be familiar with that. Okay, so if I know 2 of the measures of the angles, to find the third one, what do I do?
Add up the 2.
Yep, add up the 2 and subtract them by 180. So 180 minus the sum of 48 and 61. Okay, what is the sum of 48 and 61? What's the sum of 48 and 61? 9. And then the difference of 180 and 109. 71. Okay, so we got the measure of the third angle. Easy peasy, right?
Yes.
Now, types of triangles. Okay, knowing the types of triangles and being able to identify them is going to be useful. Based on the angles. Okay, this is based off the angles. We have 3 types: acute, right, and obtuse. Acute triangles have all acute angles. Okay, they have all acute angles. If one of the angles is right, then we have a right triangle. The other 2 have to be acute. Okay, they can't be anything else. And if we have one obtuse angle, then we have an obtuse triangle. Again, the rest will have to be acute. There's no way for us to add up to 180 with more than one obtuse or more than one right angle on 3 angles in a triangle. But if one is obtuse or one is right, then we have obtuse or right respectively. If they're all acute, we have an acute triangle. Based on the sides, we have our nomenclature. All sides are equal is equilateral. Equal sides, equilateral. 2 sides is isosceles, and then no sides that are equal is going to be a scaling. it's important to recognize these little tick marks because those measure congruency. Okay, the number of tick marks on a side will tell us, hey, these sides are going to be the same value. Okay, these are going to be the same measure. All right, so since there's one tick mark on all the sides, all three are the same length. If we look and see that, okay, I've got one tick mark on these two sides, but I have two here, that means that these two sides are the same measure, and the third one is going to be different. Okay, and then if there's different numbers of tick marks on each side, then we know that all three sides are going to be different. Now, conditions for a similar triangle. All right, the corresponding angles, the angles that match up, have to be the same measure. The sides will be different, but as long as the angle measures are the same, then the triangles are going to be similar, meaning that there's going to be a proportional relationship between all the sides. So we're going to be using proportions to solve with similar triangles. Now, just like on the side lengths, how we have the tick marks, we also have the little arcs on the angles. They mean the same thing. The same number of arcs means they're going to be the same measure. Okay? So if I have one arc, that means that these are both going to be the same measure. Two arcs, these are the same measure. Three arcs, those are the same measure. Okay? So again, recognizing that the symbols and the indications are going to be useful for figuring this out. Okay? So first we have to identify, is it a similar triangle? Okay, well, we see that I have 45 degrees. These two have to be the same. These two have to be the same. So yes, we know they're going to be similar. All three corresponding sides match. Okay? Now, since I know that A matches up and it's 45 to N, those two are the same, I want to find the other angle measures. So which side corresponds with C? Which angle corresponds with C? So the measure of angle C is going to be 104. It's going to be the same. And then the measure of angle B corresponds with which angle? 31, angle M. So it has to be 31 degrees. So those match up. All right? Now, if I want to find the side lengths, I'm going to have to use a proportional relationship. Okay? So what we're going to do to set this up is we make sure that we identify which sides correspond with each other. Luckily, these are kind of oriented the same way, but I want you to pay really close attention. They're not always going to be oriented the same way. Sometimes they'll rotate one of the triangles. And so you have to figure out which angles match up and which sides match up. Okay? So since I have C and E are going to be congruent, and A and D and B and F, the corresponding sides will be proportional. Okay? So 32 is going to be proportional to whatever this side EF is. 16 will be proportional to side 8, and 24 will be proportional to side DF. Okay? So we're going to set up a proportional relationship. I know those two corresponding sides. So I'm going to be using that ratio to start. Okay? You can do 8 over 16 or 16 over 8. It doesn't matter as long as you match it up. This relationship has to be proportional with any two other sides. Okay? So let's label this. This is the small triangle, and this is the large triangle. So I keep track, right? So one of the sides on the small triangle, I don't know. So let's say EF. I want to find side EF. Okay? What side on the large triangle corresponds to side EF? CB, which is how long? 32. Okay? So there's my proportional relationship. All right? This ratio has to be equivalent to this one. So I just need to figure out what side length would make this true. Okay? There's a couple ways to do it. If you can see the proportion really easily, by all means, go for it. But sometimes the numbers aren't pretty. And so we just need to solve by doing my most hated phrase, cross multiply. Okay? What's 32 times 8? 16 times side EF. Okay, and then how do I get side EF by itself? Divide by 16. So if I divide by 16, what's the measure of side EF? 16. So side EF is 16. Now I need to find DF. So I'm going to set up the same proportion, but I'm just going to change, because I still have that first ratio to start. So DF, I need to find what side corresponds to DF. Yeah, that's fine. You can absolutely do that. Let's do that for this one. That'll make the math a little bit easier. It doesn't always simplify, so, you know. But if it does, then let's go for it. So we'll simplify it for this one. All right. So we got 24 corresponds to DF. So let's simplify this fraction and make the math a little bit easier. What's 8 over 16 reduced to? 1/2. Okay, 1/2. So if we do our cross multiplication, it makes it a little bit easier. 24 times 1, and then 2 times DF. It's going to get us the same answer. What's the measure of DF? 12. So the measure of DF is 12. So we're able to find the two missing sides by using that proportion relationship on similar triangles. All right. Last thing to cover. I think this is last thing. Yep. All right. Same idea, but just written in a word problem. Okay. We're going to be given similar triangles. So firefighters at a station need to measure the height of the station flagpole. They find that the instant the shadow on the station is 18 meters long, the shadow on the flagpole is 99 meters long. The station is 10 meters high. Find the height of the flagpole. Since they're measuring the shadow at the same time, then it has to be a proportional relationship because it's measured at the same time. And so since they know the height of the fire station, we can write a ratio of the height over the length. Here's height, here's the length. We've got the fire station on one side, and it corresponds to the height of the flagpole and the length of its shadow. So I know the shadow has a length of 99 meters. I need to find the height of the flagpole. Okay? You guys want to simplify that fraction? Make it a little easier? What's 10 over 18 reduced to? 5 nines. Okay, now what? 99 times 5. Okay, and then 495 divided by 9. Say it again. There you go. So we know the flagpole is 55 meters high, or feet long. Oh, the flagpole is feet. That's weird. There's the medium feet. Questions, comments, concerns?